Let's talk about how we can use the angle pair relationships that we learned in the previous lesson to prove that two lines are parallel. But first we need to review something from last chapter, which is how to write a converse. For example, if I asked you to write the converse of this statement, what would you write? If an angle is right, then it measures 90 degrees. What's the converse for that statement? Well, remember that the converse of a conditional statement just flips the order of the hypothesis and the conclusion. The hypothesis of the statement we see on the screen is an angle is right, and its conclusion is it measures 90 degrees. So I'm just going to put the measures 90 degrees part first and the right part second. So my converse would look like this. If an angle measures 90 degrees, then it is a right angle. So why are we bothering with reviewing converses? Well, because what we're going to do today is rewrite each of the theorems and postulates that we learned in the previous lesson. We're going to rewrite them as a converse. In our previous lesson, we learned that corresponding angles, alternate interior angles, and alternate exterior angles will be congruent if the two lines that are intersected by the transversal are parallel. And we also learned that if two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. So what we're going to see today is flipping that order around. If I know that corresponding angles are congruent, then that must mean that the lines are parallel. Remember that corresponding angles occupy the same position. So for example, angle 1 and angle 3 in this diagram are corresponding because they're both basically in the top left-hand corner out of the 4 angles that were created by the intersection of the lines. There are actually a total of 4 pairs of corresponding angles in this diagram. Angle 1 and angle 3 are corresponding, but so are angle 5 and angle 7, angle 2 and angle 4, and angle 6 and angle 8. So if you knew that any of those pairs of angles was congruent, then you would be able to conclude that the lines are parallel because of the corresponding angle's converse. Same idea with the alternate interior angles converse. If you know that the alternate interior angles are congruent, then you can say that the lines must have been parallel. Remember that alternate interior angles lie on opposite sides of the transversal, like how 2 is on the left and 7 is on the right, and they are in between the two lines that we are proving are parallel. So angle 2 and angle 7 would be alternate interior, and so would angle 3 and angle 6. So if you knew that either of those pairs of angles was congruent, then you would be able to conclude that A and B were parallel. Alternate exterior angles converse is the same idea, except with alternate exterior. Alternate still means that they're on opposite sides of the transversal, but exterior means that they're on the outside of the two lines that we're proving are parallel. So angle 1 and angle 8 are alternate exterior, and so are angle 4 and angle 5. So if you knew that either of those pairs of angles were congruent, then you would be able to say that A was parallel to B. Now, our last theorem is a little bit different than the others because we're not looking for angles to be congruent, we're looking for angles to be supplementary. So if you have consecutive interior angles that are supplementary, then the lines must be parallel. Consecutive interior, remember consecutive means that they're on the same side, like how angle 2 and angle 3 are on the left-hand side of the transversal, and interior means that it's in between the two lines that we're proving are parallel. So 2 and 3 are consecutive interior, and 6 and 7 are consecutive interior, and if you knew that either of those pairs of angles was supplementary, that would be enough information to show that line A and line B were parallel. So let's take a look at a few examples and determine if we've been given enough information or the right kind of information to prove that line A and line B are parallel. In this diagram, we have two angles that are marked as congruent. What kind of pair of angles are they? These would be alternate interior because they are on opposite sides of the transversal, one's above and one's below, and they're in between the two lines that we're trying to prove are parallel. That makes them alternate and interior. And according to the alternate interior angles converse, if you have alternate interior angles that are congruent, then the lines must have been parallel. So can I prove that A is parallel to B in this case? Absolutely. By the alternate interior angles converse, we can say that A must be parallel to B. What kind of angles are we given this time? Well, aren't these just vertical angles? Because they're non-adjacent angles created by the intersection of two lines. So these are, of course, congruent by the vertical angles congruence theorem, but is that enough information to show that line A and line B are parallel? No. I don't even know anything about line A. There's no angles marked at the intersection of line A and line C. This is definitely not enough information to show that A and B are parallel. So just because you have angles that are congruent in a diagram doesn't necessarily mean that the lines are going to be parallel. It all depends on what kind of pair of angles they are. What kind of pair of angles are we given this time? Well, they're on the same side of the transversal. They're both under line C, and they're in between the two lines that we're trying to prove are parallel. So that makes them consecutive interior. And according to the consecutive interior angles converse, if your consecutive interior angles are supplementary, then A is parallel to B. But I don't have that my consecutive interior angles are supplementary. I have that they're congruent. Therefore, this is not enough information to prove that line A is parallel to line B. So just because you know something about one of the special kinds of pairs of angles that we've learned about doesn't necessarily mean it's the right kind of information to prove that lines are parallel. On our next diagram, we have corresponding angles. They're both basically in the top left-hand corner out of the 4 angles that are created by the intersection of each line. And according to the corresponding angles converse, if corresponding angles are congruent, then the lines must be parallel. Well, I have corresponding angles, and they're congruent, so yes, the lines must be parallel by the corresponding angles converse. What kind of pair of angles are we looking at in the next diagram? Well, they're not a special kind of pair of angles, are they? So again, just because you have 2 angles marked as congruent doesn't necessarily mean that you know that the lines are parallel. They have to be one of the special kind of pairs of angles that we've talked about. So this one, no, there's not enough information to conclude that line A and line B are parallel. And what about our last one? What kind of pair of angles do we see this time? Well, they're on opposite sides of the transversal. One is above line C, one is below line C. And they're on the exterior of the 2 lines that we're trying to prove are parallel. That makes them alternate exterior. And according to the alternate exterior angles converse, if alternate exterior angles are congruent, then the lines are parallel. And here we have alternate exterior angles, and they're congruent. Therefore, I can conclude that line A and line B must be parallel by the alternate exterior angles converse. And that's a good introduction to proving whether or not lines are parallel. In our next part of this lesson, we are going to be writing formal 2-column proofs to show whether or not lines are parallel.